Hi guys, today let us look into the four-stroke engines and study about the principle and working of a four-stroke petrol engine. Well, what are four-stroke engines? Well, these are the engines in which one working cycle is completed in four different strokes of the piston. Here, two revolutions of the crankshaft will complete one cycle. The four different strokes which are performed here are suction stroke, compression stroke, power stroke and the exhaust stroke. Well, four-stroke engines are commonly used as a four-stroke petrol engine and a four-stroke diesel engine. Well, now let us study the working of a four-stroke petrol engine. A four-stroke petrol engine works on the Otto cycle, that is, the combustion of fuel will take place at a constant volume. The charge used in this engine is a mixture of air and petrol. This charge will be ignited by the sparks generated by a spark plug. Now, let us study its working. First, the suction stroke. Well, in the beginning of this stroke, the piston will be in its top dead center and will be about to move towards the bottom dead center. At this instant, the inlet valve is opened and the exhaust valve is remained closed. Now, the downward movement of the piston will create a space in the cylinder head and hence a partial vacuum. Due to this, a fresh charge of air and petrol mixture will be drawn into the cylinder through the inlet valve. Now, when the piston reaches the BDC, the suction stroke ends and hence the inlet valve is closed. It is notable that after the completion of this stroke, the crankshaft rotates through an angle of 180 degrees, making half revolution. Next, the compression stroke. Now, in this stroke, the piston which is at the BDC will now move to the TDC. Both the inlet and exhaust valves will remain closed. As this piston moves upwards, the air and petrol mixture in the cylinder will get compressed to a high pressure and temperature. This compression process will be adiabatic, that is, there will be no heat transfer between the system and the surrounding. Now, when the piston is about to reach the top dead center, the spark plug will initiate an electric spark that will ignite the air-petrol mixture. Hence, the combustion of fuel will take place as a constant volume, since the quantity of fuel inside the cylinder has not changed. Due to this, these engines are also called as constant volume cycle engines. Hence, after the completion of this cycle, the crankshaft rotates by another 180 degrees and hence now together making one complete revolution. The energy required for the suction stroke and the compression stroke's piston movement is taken from a charged battery. Next, the power stroke. In this stroke, both the valves will remain closed. As the combustion of fuel takes place, the burnt gases will expand and hence exert a large force on the piston. This will cause the piston to reciprocate rapidly from the top dead center to the bottom dead center. Hence, this force will then be transmitted to the crankshaft through the connecting rods. This will cause the crankshaft to rotate at high speeds. The crankshaft then transmits the power through clutches, gears, etc. to turn the wheels of the vehicle. The expansion of the gases taking place in this stroke is also adiabatic. Since the actual power is produced by the engine in this stroke, the name is power stroke. At last, we have the exhaust stroke. Well, at the end of the expansion stroke, the exhaust valves will be opened, while the inlet valve will still remain closed. A part of the burnt gases, due to their own expansion, escapes out of the cylinder through these exhaust valves. Now, the exhaust stroke will begin when the piston starts moving from the bottom dead center to the top dead center. The energy for this stroke will be supplied by the flywheel, which has absorbed the previous stroke's energy. Now, as the piston moves upwards, it will force the remaining burnt gases to move out of the cylinder through the exhaust valve. Hence, when the piston reaches the top dead center, all the exhaust gas is moved out and hence the exhaust valve will close. This will complete one working cycle. The same cycle will be repeated again and again to produce continuous power. The crankshaft will complete one more revolution on the completion of the power stroke and the exhaust stroke. Hence, one working cycle is completed when the crankshaft performs 2 revolutions. Now let us look into the PV diagram, that is the pressure volume diagram for these engines. The suction of air in the suction stroke takes place at an atmospheric pressure. Hence, the line AB represents the suction stroke. Now, in compression stroke, the compression of the gases takes place adiabatically, which is represented on the curve BC. In the same compression stroke, the combustion of fuel will take place in a constant volume. This is represented by the line CD. Now, the expansion of the exhaust gases takes place adiabatically in the power stroke. This is represented by the curve DE. Also, the drop in pressure occurring from the discharge of gases due to their own expansion happens at a constant volume. This is represented by the line EB. Also, the discharge of the remaining burned gases to the atmosphere happening in the exhaust stroke takes place at an atmospheric pressure. Hence, this process is represented by the line BA. Four-stroke engines find their applications commonly in scooters, motorbikes, cars, etc. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live Magus videos for exam preparation in an hour. We start at Classfly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.